So today we will start chapter 4 of stratigraphy. This is chapter 4 for UPSC GSI means. So today we will discuss the Dharwar Craton. So Dharwar Craton basically lies in the southern India. Okay, so this is the normal generalized map. So we have already seen this is Kalatki Basin, this is Bhima Basin. This one is our western Dharwar Craton. This one is our western Dharwar Craton, and here lies the close-pet granite, and this is the eastern Dharwar Craton here. Here cyst belt is present, Nella cyst belt is present, here Kadapa basin is present, here you can see the Charnokites, and this is Palaghat Kaveri shear zone. And here lies our Pandyan mobile belt. And here Fremur line is also present, which is not mentioned in this diagram. So here Fremur line is also present, and this one here is known as Chitradurga shear zone. So this is a general diagram of the southern part of the India. So now basis of classification, how we have classified the eastern and western Dharwar Craton. So first one is schist belt. Okay, so you can see here different schist belts are present. So what is this schist belt? These are linear beds whose trend is north-northwest and south-southeast. Trending ultramafic basalt and BIF cherts and granites are also present. Now these rocks are present in both PDC and WDC. Okay, so your schist belt is present both in the eastern Dharwar Craton as well as the western Dharwar Craton. But if you see the western Dharwar Craton, it has little metamorphism. Okay, little metamorphism. And if we see the eastern Dharwar Craton, here we can see the high grade of metamorphism up to the amphibolite facies. Now second one is peninsular gneiss. So the composition of this peninsular gneiss is tonalite, tronjamite gneiss. Okay, this is also known as TTG. This is also known as TTG. Now if we see what will be the composition of this one, it basically contains the migmatites. It is highly folded, deformed, the schist belt within the peninsular gneiss. Okay, and the age of this will be your 3.3 million years. Okay, so the age of this is 330 million years. It will be 3300 million years. So this is the age of peninsular gneiss. Now if you see the general diagram of this one, so here is our close-pet granite is present, and here we see Chitradurga shear zone, and here is our peninsular gneiss is present, which is highly folded, and the composition is TTG. Okay, and it also contain migmatites. So these migmatites represent the high grade of metamorphism here. They represent the high temperature and pressure condition. Now the gneiss in the eastern Ghat have been included by granites equivalent to close-pet granite. Okay. Now there is a more gneiss in the western Dharwar Craton and more granites in the eastern Dharwar Craton. This is important point. There are more granites in the eastern Dharwar Craton and there is more gneiss in the western Dharwar Craton. Now if we see about the close-pet granite, so close-pet granite basically formed when the collision between the eastern Dharwar and western Dharwar Craton took place. So it is potassium rich, it contains microline, orthoclase and sanidine. So this is the composition of close-pet granite. So this is the composition of close-pet granite. Now the composition of this one is tonalite, tronjamite, and your peninsular gneiss is shear rich, and the age of this is 2.5 to 3. This will be billion years. Okay. Now if we talk about the charnokites present here, so the charnokites present here is defined by the granitic facies metamorphism, and it will contain basically orthopyroxene bearing granite. So the important property of the charnokite is it is orthopyroxene bearing granite. So we will see a Fremer line here, and below the Fremer line we will see the charnokites, and different schist belts are present here. Okay. Now what these charnokites are, these are smooth, greasy, shiny look due to hypersthene. Hypersthene is what? It is your orthopyroxene, and it is dark color rock. Now it is not mafic, surprisingly quartz grain are dark color. Okay, charnokites form at very high temperature above 900 degrees Celsius. So generally rock melts at this temperature, but charnokites survive at this temperature because of the influx of CO2. So because of the influx of CO2, the charnokite does not melt, and here the dark color mineral which we get is basically quartz. Now the cysts were transformed into charnokite by high grade of metamorphism at 2.6 billion years, which we found here. The rock formed in Archean and charnokitization took place in the Proterozoic. So this is very important. After the collision of eastern and western Dharwar Craton, there is a high increase in the temperature and pressure, and because of the influx of the CO2 during the Proterozoic time, the charnokites are formed. So if we discuss here the Algoma type BIF, okay, so here Archean age Algoma type BIF we can see, and at that time there is no oxygen is there. So Algoma type BIF which we see in the India, especially in this region, is of Archean age. Now we also get the Lake Superior BIFs. They are of Proterozoic time, and there is a lot of oxygen present because the great oxygenation event. Okay, great oxygenation event took place in start of Proterozoic. So we see the first red bed also. Okay, first red bed also appeared during the Proterozoic time. Now Archean BIF in Dharwar are of Algoma type. So whenever Archean BIF you will see, it is of Algoma type only. Now the cyst belt are important here because of the gold. So here the famous gold field is Kolar gold field is there, Agnigundala gold field is there, Hutti gold field is there. So these are important gold fields present in this region. Now if you see the east-west cross section of the Dharwar Craton, we will see peninsular gneiss, then we will see the cyst belt bounded by fractures. Okay, this is WDC here, and here is your EDC, and here we will see the close-bed granite. So if we see the peninsular gneiss, which is a TTG, then cyst belt along bounded by the fracture, then close-bed granite, and then EDC. Now the presence of comatiites also occur in this region. These comatiites are olivine bearing ultramafic rock. Okay, these comatiites also represent the Archean age, because these comatiites form at very high temperature, and this much temperature is present during the Archean time, which resulted in the formation of comatiites. These comatiites basically is olivine bearing ultramafic rock, and the special feature of these comatiites is your spinifex texture. Okay, it is like a dendritic type of texture, like a dendritic tree type of texture like this, which is a special feature of comatiites. Now this is the general definition of the Dharwar Craton. Now we will see the stratigraphy of the Dharwar Craton. So if you see the stratigraphy of the Dharwar Craton, it is divided into two parts, the Western Dharwar Craton and the Eastern Dharwar Craton. Okay, so these two different cratons were there which were formed during the Archean time by the nucleation and combination of the proto-continents at that time. So if we talk about the Western Dharwar Craton, so if we see the age here 330 to 3400 million years, we see Guru gneiss. Then above that we have Sagor group. Then we have Peninsular gneiss. Okay, above this we have Dharwar supergroup. In Dharwar supergroup, we have Chitradurga group and we have Baba Budan group. And above that, younger granite, Chitradurga and Chanukites. It is equivalent of close fed granite. Now, if you see here in the Eastern Dharwar Craton, we have a putative or unknown basement. Above that, we have Salim group, then Warangal group, then Warangal group. Then we see the enclaves of the older gneiss. Then we have unconformity here. Then we move to Proterozoic, and here in the Dharwar supergroup, we see Yashwantpur formation and Kolar group. Okay, Yashwantpur formation and Kolar group. This Kolar group is famous for gold. And above that, we see younger granite and gneiss, that is closepet and equivalent chanokites. So this is the generalized stratigraphy of the Dharwar Craton, and this is very important for exam point of view. Now, if we see the individually, if we see the stratigraphy of the Western Dharwar Craton, so basement is your Guru gneiss. Basement is our Guru gneiss. Then we have the age of this is 3400 million years. Above that we have a Sagur group, and this is very important. In this Sagur group, you will see the BIF. This BIF is of Algoma type. Then in this Sagur group, we will see the Comatiites, and here we will see the ultramafic layer and intrusions. So this is only 10% BIF, and remaining 90% is our Comatiites and ultramafic layers. Above that, we see the peninsular gneiss, whose age is around 300 million years to 3300 million years, and which basically contain TTG. Okay, which basically contain TTG. And after that, we will see the conglomerates here, which is unconformity. Above that, we have a Dharwar supergroup. We have a Dharwar supergroup. In this Dharwar supergroup, we have Baba Budan group, whose age is 2900 million years, which basically contain metabasalts, gabbro, comatiites, and BIF. Above that, we will again see the unconformity. Then we have a Chitradurga group. In this Chitradurga group, the composition is manganese bearing felsic volcanics, and above that we have a closepet granite. The age of the closepet granite is 2600 million years. Now if you see the stratigraphic sequence of this greenstone belt which is present here, so here this peninsular gneiss complex, and along this schist belt you will see the greenstone. Now if you see the how the layers have been formed in the Sagur group of rock, so we will see here 80 to 90% is occupied by comatiites, basic, ultra basic rock, plus basalt, rhyolite, and above that we will see the BIF, which is of Algoma type, and BIF plus grey wake, chert, and limestone is also occur, which is around 10 to 20%. Now if we see the Eastern Dharwar Craton, so Eastern Dharwar Craton is we have seen here the Sagur group is present, then Gneissic enclaves, then we have a Kolar group, okay, in this schist belt, which is important for gold. In that we have a champion gneiss. In this champion gneiss we have a felsic gneiss meta basalts. Okay. Above that we have a Dharwar batholith. The age of that is 2500 million years. Now if we see before evolution, we will see one more topic here. That is Dharwar supergroup. Okay, so Dharwar supergroup was present in both eastern and western Dharwar Craton. So the age of this is 26000 to 2800 million years. So in the western Dharwar Craton, it contains Baba Budhan group and Chitradurga group in the western Dharwar Craton. In the eastern Dharwar Craton, it contains Yashwantpur formation and Kolar group. This Kolar group contain champion gneiss, which is economically important for gold. Now Dharwar supergroup is represented by greenstone belt. Okay, so we have seen the greenstone belt how it was there, and this greenstone belt basically contain gold bearing in EDC. So important mines here are Kolar mines, which is now shut down. It was the exploration of the gold took place in Kolar before the independence of India till 1985 or 86. Around 100 years the gold has been excavated from the Kolar mines, and Hutti mines is also present here. Hutti gold mine. Now if we see the composition, if you see the Dharwar supergroup, so here we have the basement. Okay, then here we have a quartz pebble conglomerate. Then we have a Baba Budan group. In Baba Budan group, we have uh, Kalapur formation, then Alampur formation, then Santori formation, then Mulangiri formation. The composition of all those is BIF, quartz arenite, gabbro, basalt, and pyroxenite. Then we will see a disconformity here, means erosion, the period of erosion took place, and after that the deposition of the Chitradurga supergroup. So this Chitradurga supergroup contain Vanivilas formation, Ingeldar formation, and Hirur formation, and the composition of this is basically sulfide BIF, stromatolites, basalt, and chert. So this is the detailed stratigraphy of the western Dharwar Craton. Then if we talk about the eastern Dharwar Craton, so we have an unknown putative basement. Above that, the eastern Dharwar Craton is divided into two parts: Yashwantpur formation and Kolar group. This Yashwantpur formation basically contain mafic, ultramafic, and BIF, and this Kolar group contain your Sarka Sarchalli formation. Above that, this is not important. Then they have a goldfield volcanics, and here we have a champion gneiss, which is very important. So the composition of this Kolar group is Charnokites, Proterozoic mafic dikes, BIFs, cherts, pelites, and marbles. So this is of your Dharwar Craton. Now we will see the evolution. Now geodynamic evolution of the Dharwar Craton. So in the primitive time, around 3500 million year, the crust was formed and then it was consumed. Okay, means the protocontinent formed, it got consumed. Again it formed, it got consumed. So after that, what happened? Because of this hotspot activity, the formation of crust due to TTG intrusion. So TTG intrusion took place. So during this time, your Gorur, Sagur, and Peninsular is formed like this. And after that, subduction took place. Okay, like this. You can see the subduction happening here. Everything is collapsing. So this is also known as vertical tectonic or drift tectonic. So here we will see the Gorur, Sagur, and Peninsular gneiss. Now because of this subduction, we will see the green schist facies metamorphism in this area. Okay, now this lower part which melts, and again because of this melting produce the granitic intrusion. So therefore different granitic intrusion are also seen in the different part of the Dharwar Craton. After that, these two separate cratons, eastern and western Dharwar Craton, they come close to each other, and they collided, which result in the formation of different schist belts. Okay, because of the high amount of shear present after the collision, different schist belt have been developed. So amalgamation of the eastern and western Dharwar Craton took place, and which result in the formation of close-packed granite. So close-packed granite formed when the eastern Dharwar Craton and western Dharwar Craton, the collision between these two took place, and because of the subduction, granitic intrusion happened, and this granitic intrusion is later known as the close-packed granite. And this close-packed granite actually divides the eastern Dharwar Craton from the western Dharwar Craton. So here you can see this is western Dharwar Craton, this is eastern Dharwar Craton, and the subduction of eastern Dharwar Craton and western Dharwar Craton result in the formation of close-packed granite. And after that, because of the high degree of increase in temperature and pressure, and because of the influx of the CO2 here, we will see the charnocitization. So the charnokites are formed during this time, and after this charnocitization, this entire craton both have been tilted 5 degree toward the northwest side. Okay, 5 degree toward the northwest side. So this is very important. So this completes our lecture on the Dharwar Craton. In the next lecture, we will see the Singhbum Craton in detail. So thank you very much for watching this video.